Hi, everyone. Welcome this afternoon. I'm Helen Rosenfeld. I'm the Executive Director with the Massachusetts Science and Engineering Fair. So glad you could join us. We intended these talks to be a way to connect you with professionals in the field and to learn about a variety of career pathways. So I'm excited to introduce you to Joyce Wu, who works with analog devices, who will share her story with you today. On to you.
Thank you, Helen. I'm going to share my screen. Can everyone see?
Yes, that works.
Okay. Try to get rid of this. Somehow I can't get rid of the view. Okay. Well, I'll just start my talk then.
It's fully on the screen for us.
Okay. It's somehow not on mine. Let me start this pointer. There we go. Okay. Great. So my name is Joyce Wu, and I'm going to talk to you guys about my career path and also some of the stuff I've been working on or have worked on. So who am I? I'm an electrical engineer, and I studied at University of Michigan. I got my bachelor's there. I also went to grad school at MIT. I got my master's and PhD. I've worked in the semiconductor industry for over 16 years. And so I've worked in large companies and also a startup. I've worked in Japan. And right now I work with startups, actually. So I do technical due diligence of startups and bring those new technologies to market. So I'll just start with high school, since you guys are in high school. So I grew up in Florida. I grew up in South Florida. And in that area of the country, there's actually some summer programs. And I had always been interested in engineering and science. And so there was a program called SSTP at the University of Florida. And so that program was a summer program where you would work with a professor in their research group doing some research. And also they had different lectures about science and the world. And it was a really good program. And also the first time that I had lived by myself or lived away from my family. And it was a very interesting experience, living with roommates and having to cook for myself. And do research at the same time, giving reports and presentations. So it was a really good growing experience for me. And I worked, my project actually was on food science. I don't think I had a particular topic I was interested in at the time. I was interested in general in science. So my topic was on beta carotene and carrots. So I processed a lot of carrots. And so when you're in high school, also you're looking towards the next step, which is for most people, university. And for me, the choice of university was more like I wanted something which had a lot of choice. So I chose University of Michigan. It's a very big school, and my high school is also very big, so I was used to that environment. And I wanted a school that was good in a lot of different things in case engineering, I wanted to change from engineering. So Michigan is actually top 5 in a lot of different categories. So that's where I decided to go. And before that, I actually applied to some summer programs before college. And one of them was to go to a national lab. So I went to a Fermilab. And this program was for all the different national labs, they would send one student from each state to that national lab. And I chose Fermilab because I was really interested in physics. And so we learned about particle physics. And this was very interesting, meeting one person from each state. It was just eye-opening as well to meet so many different people. And you're all from the US. Everyone is kind of regionally different. I think someone had done a survey, what you call soda in each of the different states. So that was actually interesting. Some people say pop and some people say Coke. They actually say Coke. So for me, that was very interesting for me. And also I was in this other completely different type of thing called Envirothon. So this is an environmental competition. And so you can see that I was kind of doing a lot of different things on different areas. I wasn't sure what I wanted to do. So I had physics, I had environmental science, I had food science. So when I went to Michigan, I had applied directly to the engineering school. And when you're in college, you have to figure out what you want to major in. And at the time I was a freshman, sophomore, that's kind of when you have to decide. And for me, I was looking at these 3 different engineering majors: mechanical engineering, electrical engineering, and material science. And I was interested in all of them. And I didn't really know what you would do as one of these different majors. So I actually interviewed or talked to professors in each of those different fields. And for me, doing this kind of research was important to me to know kind of how to choose. And I actually also talked to my dad. He is an electrical engineer. Both my parents are engineers. And and not that I necessarily wanted to do what he was doing. He was more in computer programming. But just knowing what an electrical engineer does and how broad it can be, it's actually very, very broad in types of things you can do as an electrical engineer. And that's actually why I chose electrical engineering in the end. Actually, one of the professors told me that I should double major in mechanical and electrical, and I did think that was a little too much for me to do that much coursework. So electrical engineering is what I did choose. And I did do some summer internships. And those were at Lawrence Livermore National Laboratory, and that's in California. And I worked on lasers in the internship, and it was actually very well run. There are a lot of other interns from other places working on many different things in that lab. And also my first time living in California. And the second summer, I worked at the University of Illinois on superconductors. And it was more like a simulation, not really experimental, which I kind of figured out I was more of an experimental person and not necessarily a theoretical person. And so it wasn't that interesting to me. So I definitely knew that I didn't like the superconducting and simulation area as much as the experimental area. And this was during my college years. And at Michigan, the average time to graduate for an engineering degree is about 4.5 years at that time. So my intention was always going to take 4.5 years. And so in my fourth year, second semester of my fourth year, I looked at my coursework and I realized that I only needed one more class to graduate. And I could take that in the summer. I wouldn't need to take that the next fall. And so I actually had to kind of pivot. And instead of applying going directly into grad school, I actually had to figure out to find a job because I was already past all the deadlines for the graduate schools. It was February at that time. So for me, intending to go straight into a master's program, I couldn't do that. And so I was kind of furiously interviewing to find a job for the next year. And in that way, I actually ended up working at Intel. So this is in California, in the Sacramento area. So I moved to California and I stayed there for 2 years. I was always intending to get my master's degree. So for me, I knew I would only be there for a short period of time, but that I wanted to stay at least 2 years so that I'd get enough experience in industry. And so when I went to apply for my master's, I applied to many different schools, and the two schools I was deciding between were MIT and UC Berkeley. So for me, I actually was really intending to go to UC Berkeley. I already had a professor and a project lined up, and I had friends there. And when I visited MIT, I actually really enjoyed it, and I had a very strong opinion from my parents that I go to MIT. So and then they won out, and I did go to MIT, and so for me, it was going to be a master's program as a 2-year program. Each department at MIT is different, and the way they have their PhD program. So in electrical engineering, you apply directly to the PhD program. You don't just do a master's. You can just leave after the master's, which is fine. So for me, I wasn't intending on getting a PhD at all. It was going to be a master's, and I was going to go back to industry. And at that time, I actually found out about something. It's called the MIT Japan program, part of MISTI, which is an international internship program that they have at MIT. And when I first saw the flyers for this in the beginning of the school year, I was really intrigued because I was very interested in a lot of things about Japan, especially anime. And so I found out more about the program, and there was a lot of training that was involved in in order to join the program and go to Japan. So it required 2 years of Japanese language, history class, culture classes. We actually had some role-playing seminars. So there was a lot of training in order to work in Japan. And so I started that right away. So the 2-year program for my master's, I took 2 years of Japanese during that time as well. And it was a really, really good program. I worked at Toshiba, and this is in the Tokyo area in Yokohama. And for me, living abroad, so I did this right after my master's. So I graduated my master's and then I went directly to Japan. And it was a very good program. They have a lot of other interns at Toshiba from all over the world. And so it was kind of this where you're kind of going with this group of other interns, looking at different things in Japan and Tokyo, experiencing all these things together. And so it was one of the happiest times I've had is living in Japan. And also it was a very interesting time because you're talking to people from other countries and you're living in another country. You're living in a different culture. You're appreciating how other people live. And also that, I realized that the United States is not the center of the world. Other people do other things. They have their opinions of the United States. So it was also very interesting to hear other people's opinions from other countries. And I really think it was very valuable to live abroad and not just be a tourist or a visitor, but living there and being part of that culture, a different culture, was very important to me. Also during that time, so it's actually not that common to have that many women engineers, especially in Japan. And it was very rare that my direct boss was a woman. And I actually talked to her a lot. She was fluent in English. And so we would talk about work and the future. And for herself, she actually was getting a PhD herself. And I was asking her if I should get one. I wasn't intending to get one, and I actually had a job in industry lined up after my internship in Japan. So it was actually another change. I decided to get my PhD at that time after talking to her. So she was getting her PhD. In Japan, they have different ways to do it. Because she was already in industry, she had published many papers. She could get her PhD that way by doing research at her company, and then a professor from a university would sponsor her. So she was getting a PhD that way in Japan. So she recommended that to me. And what she said is, if you want to be doing the work that you're doing right now in this internship, you really need a PhD. And I've heard it said that you close doors when you get a PhD, but people have said then you probably don't want those jobs anyway. So you may be closing doors, but you're opening new ones, the ones that maybe you want to be opened. So for me, I did decide to go back and get my PhD. And with MIT, like I said before, that you apply to the PhD program, so I didn't have to reapply. And so I went back to MIT. I took the qualifying exams, and I also did another internship in Japan through the Japan program, this time at Hitachi. And so that was just for the summer. So I was in Japan for a total of 1 year. So the PhD program, it does take a while. My research was very experimental, in meaning that it's not theoretical. So you're working in the lab a lot, things don't work. So I had a lot of ups and downs in the PhD. And for me, I actually was looking at other things, like what else could I be doing? So I actually took classes in architecture and also in finance and marketing. So just to see what, you could take any class you want when you're in school. So I started to explore different things. And when I was finally looking for a job, there were different things that I could have tried or done. And, I could have gone back to the semiconductor industry. There was also a path for management consulting. I'm not sure if you know what management consulting is, probably you don't, but it's more like a kind of problem solving job where it doesn't have to be that technical, but like an example would be going to a factory and helping increase production or reduce inefficiencies. So that kind of job. And it's really, they hire a lot of PhDs because it really requires a lot of problem solving and accessing information that you don't normally have. So it's actually a path for a lot of PhDs. And I actually went through that interview process, but in the end I didn't make it through. And I actually found that a blessing. I don't think I would have liked that job. And then so for me, it was staying technical. I wanted to be an engineer, not necessarily a consultant. And so was I going to go to industry or a startup? And, for me, it was the time to actually go to a startup. It was something new. I've already worked in industry before, and startups are exciting. So, and the other thing is I wanted to kind of change from what I was doing before. So I was working a lot with semiconductors in fab, doing fabrication, working with silicon. So I had that experience, but I wanted to apply that to something else. And what I wanted to join was this MEMS startup. So MEMS stands for Micro Electromechanical System. And if you think about it, it's kind of like a micro machine. And so it's an electromechanical system on the micro scale. So um, here, so I joined the startup. It's called Pixtronix. And this startup was about a year old when I joined, and they were making MEMS-based displays or screens. And so I worked there for quite a long time, and through this almost this whole life cycle. So all the way to the end, we actually were acquired by Qualcomm about halfway through. So I was there for 9 years, and about the 5th year, we were acquired by Qualcomm. And at about 4 years, we were still trying to make a product. But in the end, we were closed by Qualcomm. And that's when I joined Analog Devices. So it's kind of an interesting path. I've done a lot of different things, and I kind of changed my mind a few of those times. But I think I in the end, you don't necessarily take the path that you think you're going to take. And for right now, I'm actually was working in the Analog Garage, and that's kind of a new concept. A lot of people haven't heard of it. And the Analog Garage is a kind of innovation incubator where they bring new technologies that are not part of ADI, and they bring that into company to make products. And the products that the technologies that they're looking at are in the 5 to 10 year product range. So something that will be a product in more than 5 years. So really far out. And I was working in the Analog Garage up until last month, where I was now moved to the digital healthcare. So my projects were already healthcare related, and so now I'm working mostly on biosensors, and that's kind of how I got from electrical engineering all to bio. So it's kind of a long path, but I've still electrical engineering, and I think this is well suited for me as well, just because when I was working at the startup, I was working on such a narrow focus. I was working on this one type of MEMS device for 9 years, and I didn't really see the whole field. And now in the Analog Garage is kind of the opposite, where you're looking at a very broad range of things. And I think that's more suited to my personality. So very happy in the Analog Garage and Analog Devices. So that was my general career path. I can talk a little bit now about the different things that I worked on. So at Intel, I was working on failure analysis of computer chips. And that was a good first experience right out of school, taking apart these things that people had built and figuring out what was going wrong with them. And it was well suited for my kind of critical thinking and problem solving. So I really enjoyed that time as well. And like I said before, the product that we worked on at Pixtronix was this screen or display. And in the end, it was intended for a tablet. You see, this is actually the real tablet. And in the end, every employee got a tablet. It was very nice. And the general way it works, that you have an LCD on your computer screen or your phone. And if you look at the different layers of the LCD, it would have a backlight, which is an LED backlight. So that's the source of the light. And you would have a light modulating layer. And in the case for LCD, it's liquid crystal that's modulating the light. And for our startup, we were going to use instead a MEMS layer, which is a layer of shutters that modulate the light. So instead of liquid crystal, we had MEMS. And then there was the circuitry backplane. So those are the main layers for display. But the LCD actually has several other layers, such as polarizers and color filters, which actually cut down on the light because it has to pass through those extra layers. So for an LCD, you actually have only like 25 to 30% of the original LED light coming to your eye because of all those different layers. And since we didn't have polarizers and color filters, we were getting much more light to the eye, and we wouldn't have to use such a high intensity for the backlight, and we would reduce the power needed for the display. And that's what we worked on for a very long time. And now I'm working on healthcare and biosensors. So when I first joined Analog Devices, I was working on vital signs monitoring projects and machine health, like a few different other things. I really concentrated on biosensors because I really saw that biotech is really big in Boston, and it's a big field in general. It's a new field, especially for engineers. And I really concentrated on biosensors. And so this picture here is actually a depiction of the coronavirus, SARS-CoV-2. And the startup that I'm working with is actually working on a diagnostic or a test to detect this virus. And it's very exciting right now, working with this startup. And it's affects everyone right now, this pandemic. And it's high stress, but it's very exciting. So I did work at a startup for a long time, and people think, oh, it's just for a few years, but I was there for 9 years. And the first thing about joining a startup is you choose wisely. So you do your research, like research the area, the field that it's in, the competitors. Is it differentiated? Do they have enough funding? And if you want to start your own startup, you should do this research as well. So, because once you join a startup or start a startup, you will work very hard. You will work long hours. You have high stress. There are highs and lows, higher highs and lower lows than you would have in a regular industry job. And also because you're working so hard in such long hours, make sure that you like the people that you work with, because you'll be seeing them a lot. And another thing is that you will use everything that you've learned. So I did lots of different internships. I took organic chemistry in college, and I actually had to use that in this job. So it's kind of interesting, all the things that you have to call upon, because there's so few resources, there's so few people in a startup, that you have to, be so many different things in a startup. And the last thing I just want to talk about is these little gems, the things that I've learned along the way. So one of the things that was really important to me was like studying or working abroad. I think really living in another place that you're not comfortable, and you gain a lot of experience and confidence and self-confidence in yourself. And another important thing is, you learn along the way yourself. Like how do you learn? How do you communicate? For me, I learned that I was more like an experimental, empirical person. Also, like I learned more by visual and like taking notes and like hearing a lecture or a podcast. So those kinds of things, you know where your strengths are, and then you can play to those strengths. It's also okay to ask for help. So for me, I asked professors, like, which major should I pick? I asked my managers for their advice. One thing about asking someone for help or for advice is that people are very willing to give their advice and their opinion and their help. So I think it's something that I learned over time, that asking for that advice is really valuable, because someone has already been through it before. Also, from working at the startup, be prepared for change. Things are going to change no matter what. Things never stay the same. And that was something that was hard for me to acknowledge, was that, I should be prepared for the change that was going to happen, even though if I didn't know what it was, that to not be surprised, I guess. And also leading a balanced life. So try different things. You have your main path, and to get to a certain goal, let's say for your PhD or whatever it is, for your startup or whatever it might be in the end. But the other things that you look at, let's say some hobby or some other interests, those actually could feed in, and can increase your innovation and creativity as well by doing other activities. So that's what also I've found in the jobs and different things that I've done. So that's it.
Thank you so much, Joyce. You have had such a broad range of experiences. It's fantastic. So I want to invite our participants to ask questions. I didn't mention this at the beginning, but you can either use the chat function and type in a question, and I'd be happy to ask it for you, or you can unmute yourself and ask your question directly. You can also undo your video if you'd like. So while you're thinking about your questions, I'll kick it off with a question about sort of, as you reflect back on these varied experiences you've had, maybe you have some advice to our students about like in retrospect, which things really helped sort of propel you to the next step, or where were there experiences that you didn't expect to be as profound or meaningful that ended up really helping you later on in your career?
I guess that, yeah, that's a good question. I don't think I did anything super intentionally. It was kind of, what's the next step for me? This is what I'm interested in. And I sometimes would have a reaction where it didn't work for me, and then I had to find a way to change. So I think it's, I mean, I think there's a line in like the new Frozen movie. It's like, what's the next right thing? So I think that's true. Like, you don't necessarily need to have a life plan, but it's good to know what the next step is. And one of the times where I didn't know what was going to be next was when the startup was closed, and I didn't know what I was going to do. Would I be doing the same kind of job? Would it be something completely different? And it took me a few months to actually, think about like what I was going to do. I did some traveling, so I do a lot of traveling actually, and that really helps. Being in a different place, figuring out what I wanted to do, and it was actually talking to a lot of people. So people in different fields. It might not be useful, but most of the time it is.
Thanks. We have a
Not sure if I answered the
question.
question.
I think that's fine. Thank you. We have a question here. Based on what teachers have been told over the last 10 plus years on workforce development, do you think your path will be or is typical for your generation and the next? Great question.
I would say it's not necessarily typical for my generation. I'm actually much older than you think. But I think for future, yes. And I've always wanted to keep learning. So that's kind of why I kept changing. And also, I worked in some area for quite a bit of time, like seven to 10 years. And I kind of wanted to do something different. So for me, it was always learning something new. That was what I was interested in. And for me, I do think that it's pivoting and changing the field, your field is going to be very common. And actually for your PhD, it's very rare that you would work on what you did on your PhD after your PhD.
I'm going to follow up with that question with another question. I think what we're seeing is that people stay in their jobs for fewer years than they did 20 years ago. And that every couple of years there's turnover. Do you see the same in your field? And to that point about pivoting, is that sort of a generality that others are in the same situation, or is that the startup community is sort of so fluid that there's a constant motion with people shifting jobs every couple of years?
I think it's a combination of all those different factors. So especially if you're living in the Bay Area, there's a lot of change. It's like people change companies very frequently, and it's not frowned upon. So and I think at ADI, it's actually quite different. People stay for 30 years, like very long time at ADI. And I do think it's changing already, that people don't stay at the job that they're at for very long. And I do see it happening with younger people. Like, they want to try a startup. Like, let's say they start an industry and then they want to join a startup. And I think it's a good experience to join a startup. And that's why I did it. Just because it's very exciting, especially when things go well. But you learn so many things. And actually the job, like working at the Analog Garage without the startup experience, I think that was a big plus for me, because I'm working with startups. And so I've been on the other side, and having that experience actually, which a lot of people in my generation don't have, is actually a big plus.
Great, thank you. We have a question. Could you elaborate more on the work you do with biosensors currently? It sounds really interesting.
Sure, yeah. So biosensors is a broad field, and there's different things that you can detect. But sensor means that you're detecting something or measuring something. And so in this biosensor area, it's actually a new group formed at Analog Devices. And right now, the projects that I'm working on work with startups. And the particular one I'm working on is a nanosensor. So it's on the nanoscale. And it's detecting the protein of the virus. So not the actual DNA, it's not DNA, but RNA for the virus. And that's what the current tests are detecting, are the RNA, or the genetic material. And the diagnostic that I'm working on or helping on is the detecting the proteins. So the proteins are the building blocks of life. So DNA and RNA gets translated into proteins. So the protein is what's on the surface of the virus. So you have the spike protein, you have the envelope protein, and then you have the nucleocapsid protein, which surrounds the RNA. So this particular sensor is detecting the protein. And there's different ways to detect. So could be optical, could be electrical. Those are the two main ways. And the one I'm working on is electrical based.
Hope that answered the question. Feel free to follow up with another one if there's an additional question to tack on. You spoke about a variety of people who've influenced you, particularly, I think, when you were in Japan, your boss, who sort of helped influence your decision around pursuing a PhD. For a lot of our students, finding people, how do you build, I guess the question is, how do you build a community of advisors for yourself, starting in high school, even if you can recall that, to help you make decisions around the career interests you have?
Yeah, that's a good question. It's really, I mean, I think that's an internal question. It's really like if you want to find a mentor, right? And people ask that question all the time, like, how do you find a mentor? No one really has a good answer because you have to get along with the person. The person also has to get along with you and want to give their time. And it's kind of like, how do you find friends or a partner? So let's say you have a certain field you're interested in, you can go talk to professors or people working in that field and just talk to a bunch of different people, and maybe one or two of them you'll get along with. It's hard to say like, I want you to be my mentor and then they'll be your mentor. It doesn't really work that way. So, and I've had other people say they want to be my mentor, and I'm like, okay, but then it doesn't really work out. So it's kind of where it actually has to work out on both sides. And actually, I do mentor women graduate students at MIT, and some of them work out great, and some of them don't. And it's just, every person is different. But just talking to a lot of different people, see who you get along with, and that's how it works.
Thanks. Your work is at the intersection of biology and engineering and a host of other things. Can you tell us a little bit about what some of your colleagues' backgrounds, very briefly, obviously, like, have they come at this work from the biology side or the engineering side, and how have they created that pathway for themselves, and how does it influence the work you do collaboratively?
Yeah, that's a good point. And actually, our new group has a bunch of different people from all different backgrounds. And actually, one of my other colleagues actually came from the bio route, so she's coming completely from the other end, and now we're kind of meeting in the middle. So that was interesting because I actually don't know that many people in our company who are based from biology. So that's actually a big plus for us. Most of us are electrical engineers. One of the other guys, he comes from chemistry, so his PhD is in chemistry, but he's on the marketing side. A lot of the marketing and business people come from technical backgrounds, but the bulk of everyone is really electrical engineering, computer science. In analog devices, and it's because it's a chip company. So if you're going to, let's say, a pharma company or any kind of medical device company, they're going to be more biomedical engineering based. So and we've seen that as well. So there is definitely a gap between the bio people and the engineering people, and it's bridging that gap, which people are trying to do right now. So if you're a person to bridge that gap, you're in high demand.
So if anyone has more questions, please include them now. And if not, I will ask a wrap-up question. If you were to give your younger self some advice, what would it be?
I guess, I had those little gems that I was thinking about, and I guess one of them I didn't include because for me, it's like when I say I'm going to do something, I'm going to do it. And I think for me, I would tell myself it's okay to change your mind, because I did change my path quite a bit, and it was really hard for me to make those changes internally. So it's okay to change your mind.
Lots to be learned in that process, right? Well, great. Thank you so much, Joyce, for your time today and for sharing your pathway. And thank you all who joined. Really appreciate your participation, your questions, and that you took the time as well. We're going to continue the series. We have 3 more speakers tomorrow, Thursday, and next Tuesday. That's on our website, scifair.com. And if anyone has areas of interest, the students particularly who are on, any sort of mentorship interests or speakers they'd like to hear in the future, don't hesitate to email us info@scifair.com. We'd be happy to explore what we can provide to you going forward. So thanks everyone. Enjoy the rest of your afternoon. Thanks so much.
Thank you.